Hi everybody, my name is John, and I should try to say also bonjour madame et monsieur, bienvenue à ma présentation. Is that good? Yeah. All right, awesome. Excellent. So I work as an iOS freelancer, and I also do a bunch of stuff like a weekly blog post about Swift called Swift by Sundell. I also do a podcast, which is also called Swift by Sundell, because I don't have any imagination when it comes to naming. And I also started a new podcast last week with my good friend Guy Rambo called Stack Trace. So a bunch of different stuff. I really love sharing things with the community, and I'm a huge fan of Swift. So I'm very, very happy, and I want to thank Greg for inviting me here to talk to fellow Swift enthusiasts here in Paris. It's always really, really cool. So my topic today is going to be about core animation, but we're not actually going to talk about animations today. And that might seem a little bit strange, given that the framework I'm going to talk about literally has animation right there in the name, right? But instead, what I want to talk about is a little bit how we can use core animation for some really cool custom rendering, how it can be a great tool for different types of UI and shapes and different kind of things that we might need to do in our apps. So core animation, I think, is a framework which some people might have used kind of indirectly or without really knowing it. You might be like accessing the layer property of a view and setting like the border color or something. And some people might have really dug into it and used it for like really complex animations. But I think it differs a lot, like kind of what kind of experience you have with core animation. So today I hope to both kind of show you some things that you might not know you could do with core animation, or to use it in some new interesting ways. But before we dig into the fun stuff, I thought it would be a good idea just to kind of take a look at core animation again, kind of how it fits into Apple's overall rendering pipeline, in case you haven't worked with it that much before. So as you know, when we're building apps and working, against the top-level UI frameworks that Apple provides, we're using things like UIKit, WatchKit, and AppKit, depending on the platform. And of course, this is where we get access to all the common tools that we need, like handling images or rendering labels, or even building custom views and custom subclasses of UI view or NS view. But you might know that these UI frameworks, they don't actually do much rendering. They just kind of handle the events, and they act as the kind of top-level API. Instead, you've got this like chain of rendering that kind of builds up the stack. So under these UI frameworks on all the different platforms, you have core animation. So it's kind of like a common denominator for both the Mac and iOS and Watch, which are all very different when it comes to the UI and the top-level APIs, but they are all relying on core animation underneath. And what does core animation do then? Well, its job is really to organize all of the content that we want to render into layers so that we can, render them in a nice way, and to render them using transactions. And those can either be animated if we are like performing an animation, or they can be instant if we just want to update a background color or set a frame or something like that. And on iOS, on the Mac is a little bit more complicated, but on iOS, each view has a layer that backs it, and the layers can also make up a hierarchy, so one view can have multiple layers. But core animation doesn't actually do any rendering either. In order to actually start pushing pixels onto the screen, we need to step down to metal. And this is where it gets really fun. When we get to deal with things like draw calls and shaders and actually do math, that's fun, right? And that's kind of where we program the GPU to actually display all of the content we want to display. So we're not going to go that far today. We're going to stick here in the middle in the core animation land. But this is kind of how the rendering pipeline looks from like a bird's eye perspective. And one thing I really love about the way Apple usually designs their technology stacks and their frameworks is that you have this option of stepping down to a lower level if you need to, but you don't have to. For 99% of all of the tasks that we're going to do in an app, in a typical app, we can just use UIKit, or we can just use AppKit. We don't need to step down to the lower levels. But sometimes we want to, or sometimes we need to. So one way of kind of describing this pipeline is that if we go more to the right, we go more lower level, which gives us more performance or potential for higher performance. It also gives you more potential for screwing things up, but that's another part of the story. Another kind of way to describe this pipeline is that the more we go to the right, the more scary things become, all right? I mean, UIKit these days is pretty nicely annotated for Swift, but once we go down to core animation, we start seeing things like, you know, just very string-based APIs, maybe not so nice annotations, and things like that. So it can get a little bit scary, but hopefully today we're going to make it a little bit less scary. So today I want to talk about 4 different areas in which we can use core animation that are not related to animations per se, but are more solving kind of problems that we might face when building apps, and how we can use core animations in interesting ways to solve some of these problems. So let's dive right in, and let's start talking about shapes. So shapes are becoming more and more a very important part of modern application design. You know, back in the good old days, in the the iOS 3 and 4 era, when we had this like super highly textured UIs, you know, there was the green felt in Game Center and wood and all this kind of stuff. It was very hard for a typical person to kind of design apps because you need to be like an artist, you know, go into Photoshop and, you know, paint something really complicated. But these days, it's a lot simpler. It's also harder in a way, but because you need to think more about composition and stuff. But the actual creation of these assets is way simpler because we're using more of these kind of simple shapes to create icons and to convey things like states, where we can just fill in a shape in order to show selection, for example. So this presents us with some pretty interesting opportunities as programmers, because usually, traditionally at least, we've always been using images as assets for things like icons and backgrounds and things like that. But now when we have shapes as a more and more important part of our apps, we can actually take control as programmers and bring things into code. And that is always really exciting. So let's take a look at how we can use core animation to draw shapes. Well, we're going to start by creating an instance of CA shape layer. And if you're sitting way far in the back, you might want to come a little bit closer if the text is too small. I don't know. Or maybe you can see it on the display there on the side. So we have a CA shape layer. That's a specialized subclass for rendering shapes that is provided by core animation. And in order to get this layer to be displayed on the screen, we need to add it to our view hierarchy. So in this case, we're going to add it to as a sublayer of a layer we already have, which might be coming from one view controller's view. So to start setting things up, we're going to start by setting the stroke color and the fill color of our shape. So in this case, we're going to say that we want our shape to be white, the lines to be white, and we want to fill it out with blue. So this is kind of the setup process. Now let's actually start drawing. So to do that, we're going to use a path. In this case, we're going to use an instance of CG mutable path, and we're going to start by adding a rounded rectangle. So to do that, we're going to just use the bounds of the view, and we're going to set some corner width and corner height. So if we now assign this path back to our shape and we run this little code, we're going to see a rounded rectangle in the rendered result. And that's pretty cool. We just got started. We're drawing shapes. Okay, we're warming up. That's good stuff. But the cool thing here is that we can use a CA shape layer to compose multiple shapes into the same layer. We don't need to do what we do with views usually and create these like really complex hierarchies. We can just keep drawing. So we're going to keep here and just add an ellipse to this path and then assign it back. And that way we're going to get a circle rendered inside of our rounded rectangle. And we can even use things like transforms to manipulate our shapes. So in this case, I'm going to add a rectangle, but then I'm going to apply a transform to it so that I'm scaling it by 0.5 in both the x and y axis, ending up with a rectangle in the top left corner of the screen. So this is kind of how we can get started drawing shapes using core animation. But now let's actually do something useful. So let's say we're building an app where we want to have some kind of document icon. We might be building like a document browser or something like that. So when you first look at this icon, you might be thinking, well, it's time to go to my designer and say, hey, can you please create a document icon in Sketch, export it to PNG. Oh, wait, you need @3x also. No, we don't need @1x anymore, except for it gets complicated, right? But you know what we can do? We can actually just draw this, because if we think about it, this is just lines, and they're just like connected lines. We can draw this in code. So let's take a look at how we can do that. Well, we're going to do the same thing as before. Start by creating a shape layer. We set the stroke color to white in this case. And then we're going to create some constants, one for the size of the icon and one for the fold inset, that like inset right here, how much we want to fold it. And this is a tip that I have, is like if you want to do this kind of programmatic drawing, it's usually a good idea to move things out into constants. That way you can play around with the values to see what kind of looks good, so you don't have to go through and update all of your code. Now we're going to start by creating a path again, just like last time. This time our path is going to be a little bit more complicated. It's going to look like this. Now if you've never done any kind of programmatic drawing before, this might look like really crazy, but you get used to it pretty quickly. And you can even use tools like Paint code to draw these things in visually and then generate the code, which is pretty cool. But anyway, what we do here is we start just at 0, and then we just move around the shape, ending up at the same point again. And then to add the fold, all we really need to do is move up here again, and then draw down and draw to the right. And we have our document shape. So all we need to do now is assign it back to our CA shape layer just like before, and we have an icon. And I think that's pretty cool. This is like an icon completely generated in code. So now you might be thinking, looking at this, well, this looks awfully complicated. It sounds better if my designer just does this in Sketch, right? I can just do something more fun, like write unit tests. Well, the thing is that there are some really good advantages to doing it this way. First off is, let's say we want to add another state to this icon. Let's say if the user selects a document, we want to fill it out with blue. In order to do that, if we have a PNG, we either need to like colorize the PNG, but that's kind of messy and not very nice to do. But what's more common is to just generate another asset, right? Now we have two assets to manage. We need to make sure they have both the same size. Maybe Apple launches a new screen size. We need to like export a new version. Oh, we forgot to export a selected version. You see what I mean, right? When we are using programmatic icons, well, we just update the stroke and fill color, and we're done. So I think it can be pretty cool. It's not a silver bullet. There are, of course, a lot of instances where drawing icons is not really feasible because they are too complex. But for more simple icons like this, I think it can be a really cool way to do it. Another way you can use shapes is to create really cool kind of onboarding experiences and as part of a UI. An app that I'm currently working on, which is called Motimate, we are using shape layers as part of our onboarding process. So when the user first launched the app, we generate this spotlight effect to zoom in on certain parts of the UI and then move it around in this nice way. This might look like it took a while to build, but it was super, super simple. All we needed to do was to create a shape layer, which was the rectangle of the screen, and then a circle cutout where we want to highlight the information, and then just animate over that shape. Super easy. It was just like a couple of lines of code, which is, I think, very cool. It looks very nice, and it is very, very simple. So shapes can be a very, very powerful tool. And the good thing about them is that they can be programmatically changed. So we don't need to wait for a designer to update an asset. We don't need to manage all these things. In fact, we don't need any assets at all. We can just keep it in code, which is very nice for us as programmers. Another nice benefit is that we have things that are resolution independent. That both means that if Apple launches like a new at 4x screen on the next WWDC, well, that would be crazy, right? That means that we don't need to find all these old Photoshop files and update them for the new resolution. They will already work out of the box. Also, it means we can play around with things more. For example, we might want to generate a smaller UI for like the iPhone SE and a larger UI for the iPad Pro. And we have the freedom to do that if we have resolution-independent assets. Finally, one thing you might be concerned about when doing this approach is performance. Because if you've been doing, for example, core graphics-based rendering before with these shapes, you might have been running into performance problems because core graphics is done on the CPU. It's not very performant if you need to draw big things very often. But the good thing about using CA Shape Layer is that it's really, really efficient. Core animation renders out of process for a lot of things, which means that your own main queue is free to do its own work. And it also makes heavy use of the GPU to offload a lot of the CPU-bound work, so you get really highly efficient rendering, but you can still do custom drawing, which I think is pretty cool. So that's shapes. Now let's move over and talk about replicators. Replicators, I think, is like a little bit of a hidden gem in core animation. It's something that you might not initially, when you hear about them, kind of think about what they might be useful for. I spent a long time just looking at this API and was like, who would use this? But it turns out that they are pretty cool, and you can use them for some interesting things. So what are replicators? Well, they're a simple way to take a single copy of a layer and just replicate it multiple times. And you can replicate any layer. So in this case, I'm just replicating a circle 3 times. Let's dive back into our code, and let's take a look at how we can use a replicator layer. So we're going to start by, again, creating an instance. In this case, it's CA replicator layer. And the core property that you use with replicators is the instance count. It's how many copies the replicator should create. In this case, we're setting it to 3, so we want to create 3 copies of our source material. For source material, we just want to use a normal CA layer in this case. So we're just going to create it, we call it square, and we just set its frame and its background color to blue. So a very simple layer. So to make the replicator start replicating this, all we need to do is to add it as a sublayer to the replicator, and it just starts doing its work. So if we now run this code and take a look, we see a single square. No. That was not what we were expecting, right? We were expecting 3 squares. Well, the problem is that we are not moving them. So they're actually 3 squares there, but we don't see them because they're all rendered at the same coordinates. So we need to apply a transform. So replicator layers provide this property which is called instance transform, where we can set a transform to apply to each instance. In this case, we're going to move each instance by 50 points. So if we now update, we can actually see all of our 3 squares, which is pretty cool. Another really interesting feature of replicators is that you can do color manipulation. So you can change the blue offset of each instance. Here I'm changing it by 0.3. And what happens is that each instance get a darker shade of blue when I update. So again, this is something that might not seem super useful at first. It's like, okay, that's a cool API, I guess. But you can build some really interesting things with it. So here are 2 examples. For example, you might want to build like a really cool custom background where you have like a like different shading on these rocket. I love the rocket emoji. It's like the best emoji. But here I'm like coloring it with lots of different colors. Or you might want to build like a custom loading spinner like on the right, which might look like really complicated when you look at it. But it actually turns out with replicators, it's very, very simple. Let's actually dive into that loading spinner a bit more and take a look at how that was built. So these are a lot of different, there's actually 20 different small little pieces here, but it turns out that they are all just a single little shape that are replicated multiple times. So there's just a shape layer, our good old friend shape layer that we know now. So we're just gonna call this back again and just set the size on it. And in this case, I'm also gonna modify the anchor point. The anchor point is like where you want to apply the transform to the layer. So in this case, I'm applying it to the bottom. Okay. So we know this already, setting the path and the fill color. You know, we've been through that, so we're good. We know that we can set the path and the fill color on the shape. And that's really all we need for the shape itself. Now let's get to the magic. Let's get to the replicator. So we create a replicator layer just like before, and we set the instance count. In this case, 20. So in order to fill out the whole circle with these small little pieces, we want to calculate the angle which we should rotate each instance. So I'm going to use the full circle, that is, 2 times pi in radians, and then I just divide that by the number of instances that I have. I then use that angle to create a transform, and I set that as my instance transform. And then I set the size of the replicator, and I'm done. And I think that's pretty cool. This spinner, which look quite complex, it's really just under the hood quite simple. A single shape that is just replicated 20 times. So now if I just add that shape as the replicator, then I'm finished, and I can just go ahead and ship my new cool loading spinner, which is way cooler than UI activity indicator view. All right, so replicators, they are pretty cool and pretty nice. You can create multiple copies of the same layer very conveniently. You can apply transforms and color manipulations, and that's really all you can do. And that might seem really limiting, but you can do so much with these 2 tools. And because you can replicate any layer, you can even replicate other replicators. You can turn this into replicatorception. And imagine just what you can do with that. You can do like 3D things and replicate. It's really cool. And again, we don't have to worry so much about performance because we've got Core Animation has our back. We have really highly efficient rendering with CA replicator layer. Again, out of process and a lot of use of the GPU so that the CPU is free to run our own code. Awesome. So next up, let's talk about masking. Masking is something that you probably have used. A lot of apps use masks to create like round images and things like that. But with core animation, you can go a little bit further and you can create some really cool masks that are pretty complex, but they're very easy to set up. For example, let's say we want to create like a social networking app for dogs. You know, it's like Facebook, but for dogs. It's going to be huge. My dog really likes it. This is my dog. And we might want to generate like a chat bubble here with the dog's profile picture. You know, it's really important to have a good profile picture when you're a dog. So how can we do this in core animation? Well, we can use masking for these type of things. And here's just another example I want to show you in code of how we can use masks in a pretty nice way. So we start by creating a CA layer that's going to act as our mask. And then we're going to load an image. In this case, I'm going to load a Swift icon. I'm going to set that as the contents of my mask, and I'm just going to update the size of the mask as well. Then I'm going to create a gradient, and this is a little bonus point here that you can use core animation to very easily create gradients as well, which is pretty cool. And then I'm going to just set some colors on this gradient, some just random colors, and then I'm going to update it. Is there anyone here in the audience who can read UI color? No? All right, so this is going to be a surprise then. So what do we end up with here? We end up with a Swift icon with the colors of France. Isn't that cool? Yeah, it's the best version of the Swift icon yet, right? Yeah. Awesome. So those are some of the things you can do with masks. But of course, you can do so many more things. So you could use masks to create this like slanted images using like a shape layer. So you could create a shape layer that acts as your mask and then add that to an image, and you get this really cool effect. You can also use it to apply gradients to text. So if you have a text layer as your mask and then a gradient layer in the bottom, then you can get this nice effect. You can also use it even to do really interesting things where you are using one image as the mask for another image. Talk about Inception. Here I have a space shuttle that is being masked by Saturn. And to do that, well, you just create a mask, you set the contents, and then you assign the mask back. So masking is pretty cool too. Using it, you can crop layers in many, many different ways. And the good thing about that is that any layer can be masked. So you can use any layer you want as a mask, or apply a mask to any layer. And you can also use any layer as a mask. And again, you probably know now what the last point is going to be. Well, it's highly efficient, right? It's really efficient rendering using any CA layer, which is pretty cool. All right, so we've now reached the last point. And the last point might be a little bit surprising, because I want to talk about game development. You might be thinking, okay, what does game development have to do with core animation? And why would anyone want to use core animation for building games? I mean, we have all of these game engines and tools at our disposal already, like really high-powered cross-platform frameworks like Unity and Unreal. And we have Apple's own tools for building games like SpriteKit and SceneKit. So why would anyone in their right mind use core animation for games? It kind of sounds silly. Well, it turns out that we've been talking a lot about performance in this talk and how everything is kind of, oh, it's highly efficient. It's highly efficient. Well, it turns out for games, being highly efficient is really important. And core animation is really efficient at doing some really core things that we need for games, like rendering images and textures, creating shapes, and using replicators in ways like to create platforms and things like that. And of course, we haven't talked so much about animations today, but core animation is, well, really good at animations. So that is also a great thing when it comes to games. But we wouldn't necessarily just want to build a game using core animation directly, because we want to have some kind of game engine to work with. Just like we wouldn't start an app tomorrow and build the app from the ground up with core animation, we want to use UIKit. So does that mean that we need to build a game engine using core animation? Well, the good news is I have already done that. And it's called Imagine Engine. And it's a project I started last year to kind of create an alternative game engine for Apple's platforms. because I love building games, but I got a little bit tired of using SpriteKit because it's closed source, and it was kind of hard to debug performance problems and things like that. So I thought, let's use Core Animation, which is a really highly efficient and really powerful rendering tool, and build a game engine on top of it. Now, I could do a whole talk about Imagine Engine, trust me, but I don't want to. Instead, what I want to do is I want to show you a quick demo of what it's like to build a game powered by Core Animation. Do you guys want to see it? Yes. All right, so let's jump over to a playground and do a little prayer for the Xcode god that the playground will actually work today. Let's see, it's in full screen mode, so starting good. Here we go. There we are. All right, I'm going to do this little magic trick. Perfect. Maybe I should make it a little bit bigger. Is this good? It's okay? Perfect. All right, so what do we have here? Well, we have a playground, and here I've just created a little bit of boilerplate where I'm creating a scene, which is what game engines usually use as kind of, that's their version of a view controller. It's like a way to group together content, like a level or a menu or something like that. And then I'm creating a game instance, which is really like running our game. And then I'm assigning that game's view to our playground page live view. So we see the game actually running here on the right. It's a very exciting game. It's probably going to win many awards. I call it Black. It's great. But now let's actually make it a little bit more exciting. We're going to build a game today called Asteroid Blaster, which is going to be about blasting asteroids. All right? So I'm going to start here by just creating some ground. Now, one type that Imagine Engine has is a block. A block is basically a way to create these more platforms and textures that are tiled so that you can easily create different shapes and different sizes of blocks without having to tile and stretch the textures, because that looks very ugly. So here I'm creating a block which has the size of the width and then 128 points high. And then I'm just positioning it in the scene, and I'm adding it to the scene as a child. Now the cool thing about blocks here is that if I wanted to experiment and make the block taller, I can easily do so. I can say like it's going to be 512 instead. Well, the engine doesn't have to scale the texture. It can just create more instances of it. Now you might be connecting the dots here. What did we learn about just a couple of slides ago that could create multiple instances? Replicators, right? And that's actually what this is using under the hood. It's just using a CA replicator layer to actually create this very highly efficiently. So to show you that that actually is true, what I can do is that I can set a debug flag here to show all the layers, and you can actually see that these are all the same CA layer just being replicated multiple times, which I think is pretty cool. All right, so let's move back now again to our previous size of the ground, because otherwise the game is going to be a little bit hard if the ground is all the way up here. All right, so we have a ground. Now let's start creating some asteroids. So to do that, I'm going to use Imagine Engine's timeline API that enables me to repeat a closure with a certain interval. Now, this is something that you might normally use like Grand Central Dispatch for, but in a game you want to drive more logic based on the rendering rate of the engine of the game. So you don't want to necessarily use something like Grand Central Dispatch. So I'm going to say that every 2 seconds we're going to create an actor, which is like an active game object. And I'm just going to use that asteroid texture for it, set its position to X and Y. So right now it's just being rendered up here in the top hemisphere, not very dangerous at the moment, but we can start making them move down. So let's do that. So we're going to tell the asteroid to rotate by 2 times pi, and then set a vertical velocity on each asteroid. So now we see here, we're going to start seeing some asteroids falling down. And you can see they're also layers, so they're just being rendered there using the layers as well. It doesn't look very realistic at the moment because they're just falling through the ground, right? So we need to add some explosions, I think. What do you guys think? Explosions are cool, right? Every game needs explosions. So I'm going to start by creating an extension on the actor class, which adds an explode method that's going to be really useful in this game. And what it does is it just creates another actor called explosion. It sets it to the same position. It runs an explosion animation. And then when that is done, it just removes itself, and it removes the host actor as well. So what I can do now is that I can add a collision observation so that when the asteroid collided with my ground block, then it explodes. So now if we run this, we can see, boom. I have to make the sound effects myself. So it's a little bit like, boom, budget game. But, it's fine, right? We need some imagination. All right, so now we have these crazy asteroids like destroying our planet. We can't have that. So we need to have a way to defend ourselves. So to do that, I'm going to add a observation on the clicked event. And the reason it's called clicked and not tapped is because since core animation is cross-platform, Imagine Engine is also cross-platform. So you can run the same game on iOS, tvOS, and macOS. So now, if I go here and play this game, and we click it, we can see that nothing happens. Well, that's great, right? Maybe it's the playground that is not updated yet. Let's see. No, nothing happens. Asteroid events, clicked, observe asteroid explode. Yeah, it should be. Oh, you know what? I put it in the wrong place. I put it in the closure inside of the explosion. That obviously doesn't work. It has already exploded. Demo effect. It always something needs to happen. But that's how you know it's real. It's not a pre-prepared. Boom! Now we're exploding. Yeah, now we're talking. All right, so we now have our little game here, and it's pretty cool. We can explode some asteroids, and it's all working pretty nicely. So here is kind of a cool benefit of using core animation for something like this. Since core animation is so optimized for rendering such a large amount of content, just think about how much content we're rendering in an average app these days. We have maps, we have collection views, we have all these kind of things. So it's really good at managing all these types of objects. So if I want to go really crazy and implement like an ultra hard mode for my game, where I'm like creating an asteroid every 0.2 seconds, like 10 times more asteroids, that's going to give me 10 times better reviews on the App Store, right? So now it's going to be like I have to really keep up here, And the cool thing is that the frame rate is still really good because core animation is made to handle that kind of thing. You don't have to worry, and you get really even performance characteristics. So that's Imagine Engine, and that's how we can use core animation to build some games, which I think is pretty interesting. So I showed you now a pretty simple example, but of course you can use it to create really sophisticated games as well. In fact, I'm using core animation right now to create an Imagine Engine to create my new game Revosendo, which is running here on the right together with some of my friends. And we also made some prototypes with like a really large amount of objects, and they're all animating. In this scene here in the middle, there's over 10,000 objects, and they're all rendering at 60 frames per second. And again, this is not something I can take credit for. It's core animation. It's like how powerful and how fast it actually is. So we talked about 4 different areas in which core animation can be really useful. For creating custom shapes for icons and animations and tutorial screens, for things like replicators to create custom loading spinners or interesting backgrounds and different kind of things. We've talked about masking, how that can be used to create like new custom ways to render images and to create gradient-based labels and things like that. And finally, how you can go a little bit crazy and even use core animation for game development. So that's all I had for you today. I hope it was interesting and that I've inspired you a little bit to check out maybe some of these things in core animation. Again, I'm not saying that you should always use core animation for everything. Use it whenever it's appropriate and whenever you can harness some of this power and whenever it can give you some benefits. So if you want to follow me online, I'm at John Sundell on Twitter. I usually tweet a lot about Swift, as you can probably imagine. I also run a weekly blog called swiftbysundell.com. And you can find Imagine Engine and a lot of other open source frameworks on my GitHub page. Merci beaucoup. Thank you very much.
Thank you, John.
Thanks. And I will also say the slides will be available later this week, as well as a lot of sample code. And I will also write in more detail about this on my blog as well.
Great. So, questions? Yeah. Where is the
ball? I need to throw the ball. That seems like the fun part.
Hello.
Hey.
Just a quick question about that game engine.
Yeah.
Those asteroids, so you use CI animation to animate them. It's not like you don't have a custom run loop.
It's a custom animation controller, yeah. Because it's based on the display
You use
refresh rate.
display link.
Yes, exactly.
Okay, so basically all the collision things are made using the actual coordinates of the layer, not the presentation.
Exactly, exactly. So it's using the internal game object's position, not the actual rendered position. Because if you are dropping frames for some reason, we try not to drop frames, but if you do, then you still want your game logic to work the same way, right? You still want this to be predictable.
Okay.
Yeah. Cool.
Another question. There. Bonsoir. Bonsoir.
Cool. Thanks for coming. It's great to welcome to Paris and everything else.
Thanks.
I wanted to ask, how did that work out? Actually comparing it to SpriteKit, your Imagine engine. That's cool that you've done that.
Yeah.
And, how does that work out performance-wise compared to SpriteKit?
Yeah, so one kind of key reason why I started this project was that I was using SpriteKit in a lot of games that I was building. And I realized that even though SpriteKit is amazing, it's a really great tool, and I'm very happy that Apple has provides something out of the box. There's a ceiling kind of to it, where it's optimized for a different kind of games, where maybe a little bit more simpler, not so many objects. And once you started building these large levels and this big grand scale strategy games, I saw really poor frame rates because a lot of game engines, they are linear in complexity when it comes to the amount of objects because they need to update each object on every frame. And that's how SpriteKit works, for example, for many things. So with Imagine Engine, I tried to learn a little bit from that to create a more lazily update controller where things are only updated whenever they need to be updated. And because core animation already does a lot of rasterization and things like that, and that it renders out of process and does all these clever optimizations, can get some really good performance even with this large amount of objects. So it's not apple to compare SpriteKit with Imagine Engine because SpriteKit also has a lot of features Imagine Engine doesn't have. But in terms of just sheer amount of objects, I think Imagine Engine performs really well.
Great. And what do you use for a physics engine? What do you use for physics?
So there's no physics engine built in, and instead it has a plugin system, so you could take something like Box 2D and plug that into the engine if you want to.
All right.
Yeah, it provides some lightweight physics like the velocity, but that's just linear velocity. It's not real physics. And it also provides a collision API, but that's also just hitbox text testing instead of real collision testing, physics. Yeah.
Are you going to continue the framework, or are you?
Yeah. The cool thing about it, so I'm using it also a little bit as an experiment for myself because one thing I've seen with some of my open source projects is that they tend to revolve very much around me. And I don't want that. I want them to be more community driven, and I want anybody to be able to pick it up. So one thing I've really tried to do as much as possible is to encourage other people to contribute. So whenever there's a new feature that I think of, I don't implement it myself. I put it up as a task on GitHub. So right now we even have, I think, 16 or 17 contributors to the project. So I'm still working on it, but hopefully even one day when I will stop working on it for some reason, there will be enough people to kind of continue moving it forward.
I'll try to contribute.
Awesome. Yeah, looking forward to it. Yeah, please do.
Anybody else have a question?
Yes, questions. I don't see with the.
Nobody else?
You can ask me about anything you want.
Yeah.
Oh.
I can't promise that I will answer, but you can always ask.
Well, one other thing I was going to ask you, when you were doing a lot of the drawing with the images, did you do testing for example, I use a lot of core animation for icons and stuff like you're doing.
Yeah.
And applications. And sometimes you have to weigh out whether it's cheaper to draw it or to have the image already available.
Yeah.
What point do you have some kind of criteria that you're using for that? Or?
It's usually, I mean, if we're talking about performance or complexity.
Oh, performance.
Performance.
Yeah,
okay.
Yeah.
Usually I try to measure those things. And, if you still want to draw programmatically, you can always rasterize. So you could draw once and then save that image. And you can, you probably already know, but you can super easily do that using a layer. You can tell the layer to rasterize. So yeah, I usually do that, but mostly for me, it's not hitting performance, a performance ceiling. It's hitting a complexity ceiling, where what I'm trying to draw is just so complex, too much code, And it's like the thing I showed with the document. I think that level of complexity is great for shapes. Yeah, it's perfect. But once you reach more like, really custom, like if you try to draw like the GitHub icon, I would probably not do that as a shape. That would be like pretty hard. Maybe the Twitter icon is like, I don't know.
I've seen guys that can do that, but
Yeah,
I wouldn't
it's like
try.
you can just do it a bunch of circles, right? Yeah.
Well, thanks a lot.
Yeah, no worries, thanks.
Another question.
Yeah, down there.
Hello.
Hey.
We heard that you are gonna work for Apple to fix Xcode. Is that right?
No, that's not right.
That's just a joke. The real question is Imagine Engine modular enough to port it to Android, for example? Or it just revolves around core animation?
Right now, it revolves a lot around core animation, but it doesn't. It's structured. The code is structured in a way so that the core animation doesn't like that. Those implementation details don't leak to the rest of the engine. So there's a layer type alias that the rest of the engine uses, and it uses some of the properties of the layer, but it doesn't like. That's contained in like a very small part. So if we wanted to, like, there's Swift on Android, but it's not really practically used that much. But let's say that Swift on Android becomes like a thing and a lot of people want to use it, then I don't think it would be too much work to actually abstract it out into more like a rendering protocol. In fact, I've been working on Imagine Engine for like 3 years or something, like just on and off, not every single day. I actually have a day job. But in an initial version, I actually had a protocol, like a rendering context. But I opted to actually just use core animation directly because I could make more assumptions about the rendering kind of pipeline instead of having to code very defensively. Because whenever I have a protocol, I want to code pretty defensively against that because you never know how it's implemented, right? But yeah, to answer your question, I think it shouldn't be too hard. Definitely doable.
Another question.
All right. Maybe we'll have more questions after some beers. I don't know. That's usually what happens.
That's the point.
But thank you again so much for having me, and thanks for listening. And yeah.